Okay, this is going to go into your notes. What I want you to do is get yourself a fresh page and title it Deriving Slope-Intercept Form, y equals mx plus b. Deriving means proving or use what you know to show that y would equal mx plus b. It's taking information you know and manipulating it to prove that something works. So deriving slope-intercept form, y equals mx plus b. Okay, you are going to be asked on your practice test to prove that y equals mx plus b works, given a couple situations. So the first thing you're going to prove is using the formula for slope. Okay. Now the formula for slope is the second y minus the first y over second x minus the first x, or change in y over change in x. Okay, you've seen both of these things. Now, this doesn't really help us because we want to manipulate equations and end up with y equals mx plus b. However, keeping this formula in mind is going to be helpful. Okay, so we're going to use the picture that we have to the right. So what I want you to do is in your notes, you're going to write A, so underneath the title that you just wrote, you're going to write A using the formula for slope. And then you're going to write this formula right here. And then you're going to draw this picture. So push pause and copy down everything I have written, highlighted in red. Okay, so let's take a look at how this is going to work. We're going to use the points that we have here. I have 2 points that I'm given. I have the point 0, b, and I have the point x, y. Okay, so my first point, I'm going to use the second y minus the first y. So y minus b. And then I'm going to say second x minus the first x minus 0. If I find the change in y over the change in x, that will give me my slope, or m. Okay, so the change in y over the change in x is going to give me my slope. That's how we find it, right? y2 minus y1 over x2 minus x1 equals my slope. So all I did was I took these points, even though there's no numbers here, we're keeping everything variables. I do know that if I subtract second y minus first y over second x minus first x, I will get my slope. So now we go into solving equation mode. I need to eventually get the y isolated. That's my goal. Okay, so I have to start moving everything away from that y. Now, x minus 0 is just x. So I'm going to rewrite that. Now what I want to do is I need to start isolating that y, so I'm going to eliminate this x from the get-go. Anytime you have something in the denominator, if I multiply both sides, I eliminate it. For example, if I had x over 3 equals 12, well, if I multiply both sides by 3, my 3's eliminate, because if I force that to become a fraction, I would end up with just x equals 36. That same process is going to hold true for this when we are deriving this equation. So again, use the skills you know about solving equations to help you get through this. So my x's will cancel, and I'm left with y minus b equals mx. Now I still want my y by itself, so if I had y minus 4 equals 10, I would add 4 to both sides to get y by itself. Same thing holds true here, except now I have a b. So I'm going to add a b to both sides. When I add a b to both sides, my b's here cancel, and I'm left with y equals. Now, mx's are not like b, so I cannot add them, but I can rewrite it as an expression, y equals mx plus b. So this is how you prove that the information on this graph, the basic variable ordered pairs, can actually be manipulated into the slope-intercept form equation. Okay, so that's the first one, and I want you to copy all that down. Rewatch it if you have questions. Ask me if you have questions. I'm going to put up a couple more videos that will help you get through this if the way I put it doesn't make sense. But we've got one more that you're going to need to do and be prepared for on the test. Okay, next up, they want you to use similar triangles. Oops. Let's try this again. Sorry about that. Okay, so using similar triangles. So what I want you to do now on your paper is draw a little line underneath the other one or something to separate these. But I want you to write using similar triangles, and I want you to copy this down again. Okay, now side note about similar triangles. For similar triangles, all angles are congruent, or excuse me, all coordinating angles are congruent, and corresponding sides are equivalent ratios. Okay, I want you to copy these two things down, so hit pause, and then I'm going to explain what I mean by both of these. So all coordinating angles are congruent, and corresponding sides are equivalent ratios. So copy those two things down, then I'm going to explain what that means, and then we're actually going to use that information to prove similarity, or prove the slope-intercept form. So hit pause. Okay, so all coordinating angles are congruent. Here's what that means. If I have two triangles that I'm telling you are similar, okay, I've got right angles here. Let's say this angle was 60 degrees. That means that this angle is 60 degrees, which means this angle is 30, and this angle is 30. When we say coordinating, I mean the right angles, see how they're both on this left side here? So the larger angle, let's say this was, we label these. This is A, B, C, D, E, F. That means that angle A would be equal to angle D. Angle B would be equal to angle E. And angle C would be equal to angle F. Okay, because these coordinate. They're on the same part of the triangle. So that would mean that's what we mean by all coordinating angles are congruent. Okay. When we say that all corresponding sides have equivalent ratios, here's what I mean. Okay, so we have A, B, C, and D, E, F. Okay, this when you saw the similar triangles video, let's say that we had them aside 4 here, 5 here. Let me back up because this isn't going to look right. 8 and 10, 4 and 5. Okay, that would mean that if I took this side BA over this side ED, see how those are both the left side right angle on the bottom? Okay, that means that those two would be equal to AC over DF. Okay, my bottom sides, if I put the bottom sides into a ratio, that would be equivalent to the left legs put into a fraction. So BA would be 8, ED would be 4. So basically I'm just taking this side and this side, making it a fraction. Then I'm taking 10 and 5 and making it a fraction. Do you see how they both equal 2? Those are corresponding sides. Okay, so that's just what this means. You didn't have to copy all that triangle stuff down. I just wanted you to understand what I'm talking about when I say these things about triangles. Now, the other thing that we know is that if the hypotenuse has the same slope, the triangles are similar. Okay. Probably want to copy that down as well. So we do know that if they share a hypotenuse, or the hypotenuse has the same slope, we're looking at similar triangles. Okay. So now knowing all that, we have to use this picture to prove y equals mx plus b. Crazy, huh? It's actually not too bad. All right, so here's what we're going to take a look at. Pause this if you need any of this information because it's going to disappear. Okay, so let's take a look here. If our triangles are similar, we're looking at these two triangles right here. This little guy and let me use different colors, sorry. And this guy. Okay, so these are the two triangles that we're looking at. All right. So if I were to redraw these out here, I'll draw my little guy and then the bigger. Okay. So now we're to the point where we're proving this. Okay. So let's take a look. This length right here is m on my little triangle. This length is 1. Okay, they're labeled. All right, I'm going to call this triangle. Oops. Well, we'll just call it the red triangle. Now for my green triangle, for my green guy here, this side, this piece right here is m, right? This side right here, I can't use the m, but I can look at this for a second. Let me get a different color here. If I look at this height right here, this height would be y. The reason I know it's y is because this ordered pair, it's telling me I go over x and I go up y. So this length is y. Okay. This length right here is b. The reason I know that is because this point is telling me, let me get a whole different color here. Okay, this point is saying I go over 0 up b. So for this point, I go over 0 up b. So that means my height here is b. What that tells me, now this is tricky, so just pay close attention. That tells me that this height is going to be y minus b. Okay, let's think about this a little bit differently for a second here. Let's pretend, okay, I'm going to clear these out for a second. I'm just going to pretend here for a minute. I'm going to give these numbers and just see what happens. I'm going to say this number's 8, and this number is 3. Okay? I need to figure out this height. All right? So to figure out this height, if I'm up here at 8, and I'm right here at 3, what's my height? Well, it's 8 minus 3, which is 5. Okay, let's replace these back with what I had originally. Okay. Instead of 8 and 3, I have y and b. So instead of 8 minus 3, I get y minus b as my height. Right? Stick with me here. So now, this width over here, we're going to do the same type of process. It's change in y over change in x. So this point is 0, this point is x. I need the change, so I'm going to say that this top side would be x minus 0. Now to determine the order, because I use this ordered pair, first I did this y, oops. Because I did, let me get my pen back, this y minus b, then I would say x minus 0 is my side up here. Okay. So now according to the rules that we have, they are sharing a hypotenuse. The slope is the same. So we know these triangles are similar. So I could look at my sides and say, well, corresponding sides have to be equivalent, which means this side and this side are equivalent. This side and this side would be equivalent if I put them into fractions. So I'm going to say y over b and x minus 0. So these two sides, if I put these into a ratio, they should equal these two in a ratio. Now I'm going to tell you, this is a little different than what I showed in the example, and I'm going to tell you why in a second. And I'm going to show you it could have worked the other way. What I mean is on the last example, I did the 8 over 4 and 10 over 5. And this is a little bit different, but I'm going to show you that we're still okay. Now, the reason just a little side note here, what you choose for your numerator, I chose the left side, so I need the left side here. So that's why the numerators were both the left side of the triangles. The denominators were both the top leg. Okay, so if I look here and I start solving my equation, oops, uh-oh, did I lose it? Darn it, okay, shoot, I lost it. Let me try this again. I have my two triangles, M and 1, and this triangle was y minus b, x minus 0. And so I had y minus b, oops, and y minus b over x minus 0 equals m over 1. Okay. So what we're going to do is, I'm going to rewrite this because x minus 0 I can just say is x. So I get y minus b over x equals m. I don't need the 1 either because anything over 1 is itself. Now, if you think about what we did on the deriving the slope on A, I multiply both sides by x. Oops. Because x over 1 is going to cancel over on this side. So I end up with y minus b equals mx. Add b to both sides. And I get y equals mx plus b. And that's how you derive it. Okay. Now, if that wasn't making too much sense with my fraction y minus b over x minus 0, maybe you're saying, well, Ms. Ansel, when we were talking about similar triangles, you compared these two sides to each other, like the left side and the left side, the right side and the right side. Okay, so I'm going to show you how that could still work. So here's how this could still work. How this could still work is I could say, okay, well, I'm going to coordinate these two sides into a fraction. So y minus b over m would equal then these two sides. Now, if I started with my triangle on the right-hand side, I have to stick with the triangle on the right-hand side. Okay, if you want me to color code these, let's see. Okay, there we go, that's a little bit better. Okay, so now what I'm going to do is I need to multiply both sides by m. Okay, and actually before I do that, let's rewrite this as y minus b over m equals x. The reason I'm just doing x is because x minus 0 is just x, and x over 1 is just x. Okay, so I'm going to multiply both sides by m. My m's cancel, and I get y minus b equals mx. Add b to both sides, and I get y equals mx plus b. So either way, you don't have to copy both down. You could just choose one method, but be prepared. Your test is going to have one of these two on it. You're either going to have to prove it using slope-intercept form or prove it using triangles. And again, I will have a couple more videos posted up that I found online, just in case somebody else explains it in a way that makes more sense to you than what I just did.